In this video, we're going to talk about function evaluation, so evaluating either x values or y values given a function. So first I want to define what function notation is, so we know what we're looking at. Function notation is a way to show the functional relationship between x and y. X is the input and goes in the function, in the parentheses. Y is the output, and is what you get when you plug something into the function. So it's the result, it's the answer after we have plugged in the x, we get out the y. You might also see a function instead of y equals, you might see it written as f of x equals, but f of x is just the same thing as y. So for example, if something says f of x equals 2, that's really just telling you that y equals 2. So in our first example, we have been given the function f of x equals 2x minus 8. So remember, f of x is the same thing as y, so this is really just y equals 2x minus 8. And then they have asked us to evaluate the following. So f of negative 5, f of negative 2, f of 0, f of 1, and f of 3. Just like we said before, x goes in parentheses, so all of these numbers represent x values. And so we're going to take each of those numbers and we're going to plug them into the equation for x, and we're going to get out a y value, which is what our our line here represents. That's our y value as our answer. So let's start with our first one. So we're going to plug in negative 5 for x, so f of negative 5 is equal to 2 times negative 5 minus 8. 2 times negative 5 is negative 10, minus 8 gives us negative 18 as our y value. So we could also write this as the ordered pair, negative 5, negative 18. Two ways to represent that information. Okay, then we'll move to our next one. We're going to plug in negative 2 for x this time. So f of negative 2 is equal to 2 times negative 2 minus 8. 2 times negative 2 is negative 4. Minus 8 gives us negative 12 as our y value. Moving on, we're going to plug in 0 this time. So f of 0 will be 2 times 0 minus 8. Anything times 0 is 0, so 2 times 0 is 0, minus 8 gives us negative 8 as our y value, so that would be the ordered pair 0, negative 8. Then we'll plug in positive 1, so f of 1 will be 2 times 1 minus 8. 2 times 1 is 2, minus 8 gives us a negative 6 as a y value, so the ordered pair 1, negative 6. And then lastly, we have 3, so f of 3 is equal to 2 times 3 minus 8. 2 times 3 is 6, minus 8 gives us negative 2 as our y value. So that would be the ordered pair 3, negative 2. So anytime you see a number in parentheses next to that f of some number, that just means they've given you the x value. You're going to take that x value and you're going to plug it into the equation so that you can get out your y value as your answer. In our next example, they've given us another equation, y equals negative 2/3 x plus 1. Remember that y is the same thing as f of x, so this is really just f of x equals negative 2/3 x plus 1. They're the same thing. But if you notice, this time they've asked us to evaluate, and really that probably shouldn't say evaluate, but we're solving for the following values. They've told us that f of x is equal to negative 2. So they are telling us that y is equal to negative 2 this time, because that negative 2 is on the other side of the parentheses. It's not in parentheses, it's out of those parentheses on the other side of the equal sign, so that represents our y value this time. They've also told us f of x equals 1, so we know y equals 1, and they've told us that f of x equals 7, so they've told us that y equals 7. So this time we have the y value that we're going to plug in, and we're going to solve for x this time. So we're going to take that y value and we're going to plug it in on the other side of the equal sign so that our equation is now going to read, oops, negative 2 is equal to negative 2/3 x plus 1. And now we're just going to get x by itself. So using our solving steps, we're going to work backwards through PEMDAS. So we're going to subtract that 1 first. So we have negative 3 is equal to negative 2/3 x. And then to cancel out that fraction, we're going to multiply by the reciprocal. So we're going to keep our sign, but we're going to flip the fraction. So we're going to multiply by negative 3/2. We're going to do the same thing on the other side of the equal sign. And this just allows those 3's to cancel, those 2's to cancel, and then a negative times a negative becomes a positive. And then this leaves us with x equals. Now when we multiply a fraction times a whole number, remember that a whole number is really just a fraction over 1. So we multiply straight across, so negative 3 times negative 3 gives us positive 9, and then 2 times 1 gives us 2. 9 over 2 cannot be reduced, so that is our final answer. Just going to write that a little nicer. So x equals 9/2. You could also write that as x equals 4.5 if you wanted. So this would be the ordered pair, 9/2, negative 2. So let's try that again, this time with y equals 1. So we're going to have 1 equals negative 2/3 x plus 1. And again, we're going to solve for x. So we're going to subtract 1 from both sides. And that leaves us with 0 equals negative 2/3 x. And then just like last time, to cancel out our fraction of negative 2/3, we're going to multiply by negative 3/2 on both sides. So our fractions cancel on the right there, and we're just left with x equals. Negative 3/2 times 0, anything times 0 is 0, so x is equal to 0. So that would be the ordered pair 0, 1. That would also be a y-intercept. And then lastly, with y equal to 7, we're going to have 7 equals negative 2/3 x plus 1. We'll subtract 1 from both sides so that we can get x by itself. That gives us 6 equals negative 2/3 x. And then to cancel out our fraction, we'll multiply by the reciprocal, so negative 3/2. All of those cancel, so we're left with x equals. And then negative 3/2 times 6, that's really just 6 over 1. So negative 3 times 6 gives us negative 18. 2 times 1 gives us 2. We can simplify that this time, so x is equal to negative 9. So that would be the point negative 9, 7. So with function notation, that's just a way for us to kind of organize information in a sense and give a name to a function. I didn't mention that earlier. In the next section, we'll look at different names of functions. We've named all of these functions f of x, but sometimes you might see g of x, h of x, k of x with different letters there, just so we know exactly which function we're talking about. But if we have a number that shows up inside parentheses, we know that that's an x value. Just like we had in that first example, if it shows up outside the equal sign, outside those parentheses, that's a y value, just like we saw in example 2. So in our last example in this section, we're going to do the same thing, but we're going to do it from a graph. So first, let's start with this first column. They've asked for f of 0, f of 1, f of 4, f of 6, f of 8. Those are all x values. And we're going to use our graph to evaluate those x values. Just like when we were evaluating up above with an equation, everything in these blanks here is going to represent our y value. So we're going to use the graph to find the ordered pairs so that we can find the y value of each of these ordered pairs. So starting with 0, x is 0 right here on the y-axis, so we're looking for where our graph touches where x is 0, and it touches at the point I've drawn there. So then for your answer, we're looking for the y value at that point, and the y value there is positive 1. So f of 0 equals 1. Then we're going to do the same thing with f of 1. So we're going to go where x is 1, which is right here, and we're going to see where our graph hits x equals 1, which is at that point I just drew, and the y value of that point is positive 4. Okay, then we're going to find where x is 4, and we're going to see where it hits the graph, right here on that flat segment, and that y value is 7. Okay, then for f of 6, 6 is right here. It hits our graph at the peak right up there. That y value is 9. And then to finish up our x values, we're going to look where x is 8. It's right here, and the y value at that point is a positive 4. So notice those y values of 4 repeated, and that's okay. All of our x's are different, and that's what we're looking for when we look at a function. Now, opposite of that, they've also asked us to find f of x when f of x equals 1, when f of x equals 4, and when f of x equals 9. So in this case, they have given us the y values, and if they've given us y, then we need to find x. So we're going to do the same thing, but we're going to work backwards. We're going to be looking along the y-axis this time since we've been given y values, and we're going to be answering with x values. So when when y is 1, that's this line right here. I'm just going to draw it in as a dashed line. And it hits at our graph hits that dashed line at 2 different values. The first one being our y-intercept there where x is 0. And then the second one right here, we're just going to evaluate that. It's a little bigger than 9, so I'm going to say maybe 9 1/3 or 9.3 repeating. So we actually have 2 x values as an answer this time, and that's okay. All right, then let's look at when y is 4. So again, I'm going to draw that in as a dashed line. And we have 2 places where our graph has a y value of 4. It has it at 1 and at 8. So we have 2 answers again at 1 and at 8. And then lastly, let's find a color we haven't used. When y is 9, drawing that in as a dashed line, there's only 1 point when that happens, and that's an x value of 6. So depending on which variable you're given, that depends on which axis you're looking across, and then you just see where does that graph hit, or where does that value hit our graph, and you're just telling me the other number in the ordered pair. So if you're given x, that means you're looking for y. If you're given y, that means you're looking for x. So evaluating functions just means we are plugging in what we're given. Sometimes if it's in parentheses, that's an x. If it's outside, that's a y, and we're solving for the remaining variable in our equation.